to our topic, that is the reflection and curved surfaces. So yesterday we were discussing definitions, a few definitions. Okay, just I will recapitulate those definitions and then we will proceed to the remaining topic. Right. So what are all the definitions we have discussed yesterday? So that is, so if I don't remember. So already. So along with this, we have also discussed. So these are the definitions, and other than the number of curvature propellant, and then we have the principal axis, principal axis, and then okay, image distance, object distance, okay, object distance. So object distance, and then this is object distance. Well, we have magnification. Okay, etc. So before this, we have discussed about this reflection, loss of reflection. Those are the basic points which we have discussed earlier. That means that is prior to this one. Okay. Now, first of all, coming to what is pole. Okay, here. So if we draw the diagram, okay, of a concave mirror, or whether it is a convex mirror also, and suppose as our topic is concave mirrors only, so we will proceed with the concave, right? So this is the and then okay, so this is pole, and then this is focus, this is proper layer, okay, and then this distance is focal length, focal length. Then from here to okay. So this is that means from pole to center of curvature. Okay. So R is nothing but the radius of curvature. So this focal length. Then suppose you are keeping an object. Okay. Some object. Okay. This is object. Object. Okay. So the distance from mirror to the object. Okay. So from here to object distance. Right. Okay, students, are you getting to the distance? So, okay, right. So once again we will try to define these things. So simply, okay. So pole is nothing but the geometric center. The geometric center of the mirror is called pole. Okay. So this is geometric center of the curved mirror. Curved mirror is called its pole, right? So it's called it pole. Okay. It's called it pole. Then next focus or focal point, focal point or principal focus also we can call principal. So mostly we use the word focus. Okay, principal focus. That is, so what does this mean? The point where the reflected rays or the extended reflected rays meet on the principal axis. Okay, the point where the reflected rays or extended reflected rays meet on the principal axis. Principal axis is called focus of the mirror. Focus of the mirror. Understood, students? Are you getting this? So yesterday I have drawn diagram also for representing this one. So roughly, if you want, once again we can draw this. Suppose if this is a concave mirror, this is a concave mirror. Okay, and then another convex mirror. Okay, so this is a convex mirror. So what is the difference here between the convex and concave mirrors? In a concave mirror, the bulged, that means the end which is bulged inside is the reflecting surface. Okay, this is the reflecting surface. Okay. And the other surface is silver. So here, this is the reflecting surface. Okay. Suppose here, if we are keeping an object, then what happens is the rays, light rays that are coming. So what happens? Okay, they converge at a point. Okay. So if we take any two light rays, okay. So like this, if we are taking any two light rays, so after reflection, what is happening is here an image is formed. Okay, an image is formed. So this image is what is it is formed by intersection of these two rays. Yes or no? Intersection. So, but if you take here, what is happening here? Okay, if you take any rays, any two rays. Okay, right. So, roughly. Okay. So, after that, what happens is these rays get reflected back like this, or else you can draw this figure like this also, no problem. Okay. So, what happens is, so you extend this, and you will find that some diminished image here. Here, the image is always diminished. Okay. So this is the direction of the thread. So anyway, here, or else if we take some other example on this concave mirror. Okay. So the example we take yesterday was some general example I will take. Okay. Suppose and now we draw just the light rays. Okay. Two rays above one mirror. Okay. So these rays are divergent. Okay. The rays that fall on a convex mirror. Okay, they are pierced. So if you look at this extended rays, that means if you draw these rays backward, okay, so they appear as if they are coming here. So now this is the principal aspect of the focus. Okay, image and object distance means you can think this one. Okay, so like this we get even for this mirror also, but for okay this object distance means speed. So from the mirror, from this point is the object distance. Okay, if you keep some object here from here to here, this also will be the object distance. So this is the focus for this mirror. So for such mirrors, then if you have to draw the focus means okay. So see, suppose I am taking two light rays here like this, and this is coming like this. Okay. So this is the focus. Is the focus. So this ray is getting reflected back like this, and this is. So they both are converging here. Okay. So concave mirror. So for explanation of focus. So focus here, focus here. So here the light rays are here. How do we get focus here? The light rays are actually intersecting at a point, but here the light rays extended reflected rays, or here the reflected rays are actually meeting at a point, but here the extended reflected rays are meeting at a point. Now coming to this object and image distances. So for this you take anywhere. Okay. So now this is the focus concept now. Okay, right. So we shall take the distance of the image. Okay. So one ray will take here like this from the top of the object. So suppose an extended object is like this. So one ray we are drawing from the tip of the right, and then okay, instead of this ray, we will get some other. Okay. Right. So this ray is also getting reflected back because it is a diverging mirror. No? So as it is a diverging mirror, so this ray is getting reflected back like this. So if you extend this, you get a mirror at some point, but it is electromagnetic, but it is diminished in size. So example for such a okay, this is the object, and this is the okay image. This is the image. So generally, the image obtained by convex mirror is always less in size than the original object. So you can observe this in your this one vehicles. This rear view mirrors will be there. No? RVMs we call. RVM means what? Rear view mirror. Rear means what actually? Suppose this is my front and this is my rear view. Okay, front view, rear view means back view. That's all. Simply to say the things that are coming from the back side or the view of the back. Okay, so it is essential for every vehicle, no? Right. So like this. So we get the idea of this object and this is the image here. So now this is the V, that means image distance. Image distance. So how will you define object distance and image distance? The distance of the object from the pole. The distance of the object from the pole. So all distances you have to calculate from pole only. So from here to here, this is the object distance. So this is U and this is V. So from pole to the this one, this point. So this will be the image distance for the forward for the concave mirror. So here, if you take here from pole, this is the pole. So from pole to object, this is the object distance, and from pole to image, this is the image distance for such kind of mirrors. Means what? This is convex mirrors, right? So you got the idea of object distance and the image distance. So now let us write the definition for this one. Okay. Okay. So, like that you can see, how do we define or how do we write the definition? Right? The distance of the object. So, all the distances we are taking from the, are measuring from what? Measuring from pole only. So, that is one of the sign convention rules. Some I have told you. So, the rules that already are discussed. Now, let us write the definition for object distance. So these definitions yesterday we have already written, so no need of writing them now. Focal length we write. Focal length. Next is focal length. So the distance from pole to focus of the mirror. Okay, of the mirror is known as its focal length. Okay, it's focal length, right? So focal length. Then what is remaining is okay. Then principal actions we have written this one also yesterday. And then image distance and object distance we will write now. So object distance first. Object distance. Object distance. So what is the object distance? From where we have to measure the object distance? We should measure the object distance from the pole only. Okay. So object distance is the distance of the object from the what? From the pole. Okay, this is very important. Pole is called object distance. Object distance is denoted by small u by small u. The alphabet U lowercase. Next, similarly, image distance. Simple things only. Of course, these are all simple. Only I am reminding you. That's all. Okay. So image distance. Image distance. So image distance is nothing but the distance of the image of the image from the pole of the mirror, from the pole of the mirror. Okay, is called image distance. Is called image distance. Right. So these are the basic definitions what we have here. And then, okay, finally magnification. Because I will write it later. Otherwise, if it is visible, I can continue here itself. Okay. Okay. it is getting cut. Right. Okay. So just we will have a quick look at this. So pole is nothing but diameter. Focus or focal point or principal focus is nothing but the point where the intersecting point where the reflected rays or external reflected rays meet on the principal axis. Meet on the principal axis. The point should be on the principal axis. Then focal length is nothing but the distance from the pole to focus. So pole to focus is called as the focal length or its principal focus. Okay, right. Focal length. Sorry, focal length is the distance from pole to focus. Finished. Then object distance of the object from pole. Okay, distance of the object from pole of the mirror. Then image, distance of the image from pole of the mirror. So then we have magnification. So then we have magnification. Magnification is defined as the ratio of height of the image to the height of the object. Okay, it is the ratio of height of the image to the height of the object. Or otherwise also it is also defined as ratio of the distance of the image from the distance of the distance of the object. Okay, ratio of height of the image to height of the object, or otherwise ratio of distance of the image to the distance of the object. Okay, so that is the simple definition for magnification, and mostly we use this minus sign. Okay, so very simple concept, that is magnification of the. So how do we define the magnification? Let us see. Right. Okay, friends. So we have, let us see the definition for magnification. So that it is clear. Right. Now, so if we see the definition for magnification, so it is the ratio of, okay, the ratio of height of the object to height of the image. Height of the image, sorry, height of the image to the height of the image to the height of the object. Okay, height of the object is magnification. The same definition you can also write as, okay, the ratio of the same ratio of okay, distance of the image, okay, distance of the image to distance of the object is called magnification. You can write any one, both are correct only. You can write any one. Any one is considered as correct only, magnification. Okay, yeah. Okay, so here, if you are giving here is m is equal to, finally, after you write m is equal to, is the ratio of rate of image by rate of object. Or m is equal to, or the same thing is equal to equal to minus V by U. So this is our magnification concept of magnification formula, right? So now coming to the sign conventions. Now finally sign convention. Okay, before this we have the mirror formula. Okay, so another thing what we have here is the mirror formula. Mirror formula. Okay, is defined as 1 by F, 1 by U plus 1 by V. Where F is the focal length, U is the object distance, V is the image distance. So to use this one, we have to follow the sign conventions. Okay. So to use this, we should follow sign conventions. So what is sign convention? It is a set of rules. It is a set of rules to make our calculations clear. Okay, the set of rules to be followed. Okay, while taking measuring the distances or while okay, whether it is the object distance or image distance or focal length, radius of curvature, and again the height of the image, height of the object, etc. So, what are the sign convention rules you can see? The first and foremost rule is all the distances should be taken or measured from the pole. Okay, all the distances, should be measured, from the pole of the mirror, pole of the mirror. So most of the distances, unless it is the object of the image distance. Okay, most all the distances are okay measured from the all the distances are measured from the pole only. Unless it is the object height of the object. Okay, height of the object. So if you are having height of the object, then you will measure from here to here, something like that. Okay, right. So okay, this is the first one. Then second one. See, okay, I'll elaborate this. So you are speaking that all the distances are should be measured from the pole of the mirror. So if you want to measure the see focal length. So from pole to here. Okay, from pole to here. So like this. From pole to here. From here to here. Like this. Then you want to measure the radius of curvature. See this distance. So radius of curvature. So from point P to here, like this. Radius of curvature. And then you want to find the object distance. See from here to here, like this. Okay, from pole to the object. Okay, so like that you have you have to measure all the distances from the pole only, unless it is the height of the object. So this height of the object you will measure here like this. You will measure from here to here like this. And if it is down, then you will measure like this. Down. Okay. So in this process we have some more rules. So what is the case? The distances measured in the direction of incident light rays are to be taken as positive, is plus sign. Okay, to be taken as positive. Okay, then exactly opposite. So the next rule is see distances measured in the direction of incident light. Suppose how the incident light see. Suppose we need to see this object image. The light rays are coming like this and falling. The light rays are coming like this, and then they are falling on the mirror, and then they are reflecting that. So they are converging. Okay, so concave mirror is a converging mirror. It will make the light rays to meet at a point. Converging means what? Okay, converging mirror means the mirror which makes the light ray to meet at the point. To meet at the point. Okay, diverging mirror means the mirror which makes the light to move away from the point. So converging beam, diverging beam. So converging beam means the beam of light which meets at a point, and diverging beam of light means the beam of light which moves away from the point. Moves away from the point. Suppose if you see the headlights of a car, the headlights of a car make the light beam to move away like this. So like this. So they will fall on the other person. That means the lights will be seen by the opposite person. Okay, the driver of the other vehicle. Right. So here, coming to this point here. So what do we have? A distance measured in the direction of incident light. So incident light means the light rays which are coming like this. Okay, the light rays. So how can we see this one means the incident rays are, suppose you keep a torch, or even if no torch is there also, if the object is placed here, how should we think that the incident rays are passing in? It should be like this. So this is the direction. Okay. Then if we are measuring, okay, this is the direction of the incident rays. Now you should measure in this direction. All the measurements are from pole in this center. So you are measuring like this. You are measuring, see, like this. The direction of the light is like this. You are measuring like this. So in such a case, you should take the measurements as negative. Okay. So the distances measured. Okay. Distances measured opposite to the direction of opposite to the opposite to the direction of the incident light rays, opposite to the direction of the incident light rays. Okay, incident light rays are to be taken as negative. Okay, negative. This is the other rule. So I'll explain this with the help of the diagram of course. Okay. Then fourth one is heights measured above the principal axis. Heights measured above the principal axis. So this is positive, and the distances measured in the opposite direction are taken negative, and this one is should be taken as positive. The distances measured like this are to be taken as negative. Okay. So simply all the distances are to be measured. Okay. So suppose if you are measuring like this only, okay, then you can take them as positive. That means the direction of light rays. But opposite means you have to take it as negative. And any image, see here the object is here like this now. So you are measuring above the principal axis. So such a distance you have to take it as positive. And if the image, most of the cases we get a inverted image or the concave mirror, and such distances we are supposed to take as negative. Okay. So distances measured. Okay, right. So distances. I will keep both the points in one single point. Okay. Distances measured above the principal axis. Principal axis are taken positive, and those measured and those measured below the principal axis, are taken as negative. Right. So I have kept both of them in one single point. So I hope you are able to understand this. Students, go to that once again. Okay, so here, so to understand this, let us try to understand with the help of a diagram. Okay, so I'll keep this one, I'll rub all this so that you will understand very thoroughly. Just a rough diagram. So I'll take two mirrors, both the mirrors. Right. So now, with the help of these diagrams, let us try to understand these two concepts. So we will have this as the values. So values of the signs of this sign. So signs of U, V, F, comma, are for convex and concave mirrors. Okay, let us see with the help of diagrams. So this is the object. And here also we draw this mirror. The mirror AB we will name it. We will name this also as something like M. So mirror M. So this is convex and this is mirror. And this is your convex mirror. Convex mirror. Now, okay, let us try it. So except in one case, okay, right. So now here we keep an object, extended object. This is the object. And now if you calculate, see, this is the pole, this is the focus, this is the center of curvature. Similarly, here also we will have pole, focus, center of curvature. Whether it is a convex or concave, whether it is convex or concave, R is always equal to 2f. You take any mirror, R equal to 2f for either of the mirrors, right? So now here if you see, for this mirror, if you want to measure the focal length, so first of all, focal length. See, from here to here we will measure. That means this is the direction of incident rays, incident incident light rays, and even here also. Okay. So here also, this is the direction of incident Ray means the light rays. Okay. So now here you are suppose. So if this is the light ray coming from here. So this is forming an image somewhere here. Forming a image somewhere here. So suppose if I draw this passes through the focus. So you know very well that the ray the ray passing parallel to the ray passing parallel to the principal focus passes through sorry the ray passing parallel to the principal axis passes through the focus. So one of the rules already we have studied or we have told you also. So one of the ray is passing like this. So another one is we take. Okay. Okay, it is like this. You will get the image here. It is here. Okay, so this is your image. Okay, at this point. So this is I. Right. So and this is the incident ray, something like this. So this is reflected. This is another ray. This is the reflected ray. Okay. So here students see here. Now first we are measuring the focus. So this is focus. Now f is equal to we have to measure like this. Okay. So we have to measure from here. But the incident rays are like this. So as per the sign convention, distances measured in the direction of incident light rays have to be taken as quality. We are not measuring anything here like this. But we are distances measured opposite to the direction of the incident light rays is like this. This is what. So this is the direction of the incident rays. This is the direction we are measuring from the pole only. Every measurement from the pole only. So from here to here. So therefore, our focal length, whatever the value is, the f is negative. F is negative for this one, concave. Next step. Even the radius of curvature. So this is also negative because from here to here we measure. Then object distance u is also negative because from here to here we measure. Then image distance. So that is also negative. Okay. Except only one case. Okay. Only in one case we will have the image here. Okay. For this concave mirror means when the object is placed between pole and focus of the mirror. See here. Here. When the object is placed between pole and focus. So roughly if you have the diagram. Okay. Look here. Okay. This is the focus. This is the center of curvature. Now, when the mirror, when the object is kept here only, when the object is present between the pole and focus. So this is your pole. Okay. The only case and also important case. Okay. When the object is here like this. So one incident ray. So this ray is coming like this. So another ray will be placed like this. So that is passing through the center of curvature. Okay. So center of curvature. The ray is passing again through the center of curvature. So here this ray is coming back like this. So what is happening is okay. So they both are not parallel. They both are not parallel. Hence they appear to be like that. So the size is enlarged. So when the object is between pole and focus. So very important case. So in many exams this have asked. That means when this chapter was there for 10th class, okay, only this was asked for 2 marks or even 4 marks also sometimes. So only in this case you will have this b is equal to positive because you will measure the distance from here to here. Except this, almost all the cases you will get all this as negative only. For what? For the concave mirror. For the concave mirror. So understood this diagram. So this is the ray diagram. What you have for what? When the object is present between pole and focus, you get a virtual image. That also virtual image. Okay. So here when we discuss regarding the virtual image and real image, suppose okay, what should be? How should you define a real image means? The image formed by the actual intersection of reflected rays. The image formed by the actual intersection of reflected rays is called as a real image. Such an image can be caught on the screen. Your definition should be like this, not based on the catching of screen. Of course, real image can be got on the screen, but actually, what is the basic concept means image formed by intersection of light rays like this, or intersection of reflected rays like this, is a real image. Such an image can be got on the screen. Such an image can be got on the screen. Okay, so generally how people will be defining is the images which can be got on the screen are called real images. I don't say that it is wrong. Of course, it is correct, but better definition. What is the standard concept? What is the actual concept for the real image means it is basing on the intersection of the reflected rays or not. That's all. Okay. So in such a case, suppose if the image is formed here by the okay, if the image is formed by intersection of extended rays, then what? Then such an image is called as virtual image. Okay. So your definition should be based on the what? Whether the intersecting of the reflected rays or intersection of extended reflected rays. If the actual reflected rays are intersecting, actual intersection of the reflected rays, then the image formed is called as a real image. Otherwise, if the image is formed by the extended reflected rays, for example, your plane mirror, the image formed by the plane mirror is also is due to the meeting of or the intersection of extended reflected rays only. Okay, you can't catch it on the screen. It appears as if the image. Suppose if we see in a mirror, our image appears as if it is behind the mirror. Okay, so that means it is not formed by the actual intersection of reflected rays like this. It is formed by the intersection of extended reflected rays. So such an image formed by or the image formed by intersection of extended reflected rays is called as virtual image. So most of the images formed by the convex mirror is a virtual and diminished means reduced in size. It will be many times less in size than the actual object. Suppose if you are able to see the image of a lorry, okay, image of a lorry in your side mirror. So the size of this image of the lorry is not equal to the actual size of that lorry, no, or bus, no, like right. So it will be many times diminished. That means actual the size of the image which we obtain in the convex mirror is very diminished, very much diminished. Okay, very much reduced in size. Right. So coming to the convection. Now here for such a mirror, that is for the concave mirror, focal length is negative, and then radius of curvature negative, object distance is negative, image distance is negative, except this case. Only in this case you get a image distance positive. Okay, so come to this one now. Now, when we come to this, so here we measure all the distance here also from the pole only. We measure all the distances from the pole only. Okay, so like that. So we extend this somewhere here. So this is formed, the image is formed here. Right? So whatever. So here the image is formed. Now, if you have to measure the object distance, okay, here also what is focus? Here it is focus. See? For the okay, I think it is not clear. Okay, once again. Suppose when you are considering a convex mirror, and then see, suppose I draw two light rays that are incidentally on this and getting diagonal. So what is happening here is, so this is the point focus, and then this is the center of curvature, and then this is the pole. Object and image distance we will discuss afterwards. So now here, okay, incident rays. So this is incident ray. So this is also incident ray, right? So when you look at this, see all the distances that are taken in the direction of the incident rays. That means if you are measuring like this, anywhere, let it be from here, or here to here, whatever it is. So if you are measuring any distances in this direction, means in the direction of the incident rays, in the incident rays, all such measurements you can take it as positive. So for example, focal length. So focal length you are measuring from the pole only. So from here to here. So therefore F is positive. F equal to positive. Then even curvature also, center of curvature also. So this is also positive. Sorry, radius of curvature. So radius of curvature is also positive. Now object distance. So object is here. Object is here. So you will measure from here to here. So but here what do you get? U equal to negative. U is negative. But image is from here now. See, its image will get somewhere here. Okay, behind. So here somewhere we get the image. So image is here. V equal to positive. So for all the see for convex mirror except the object distance, all are positive only. All are positive only. Always it is like that. Okay, it is always like that. So I hope you are able to understand this. So once again I revise. See here the signs of U, V, F and R. So these are the only most of the things what we use generally in our problems or in our calculations. Okay, so focal length from here to here, opposite to the direction of the incident rays, so negative. Even radius of curvature negative. Object distance negative. Image distance negative. But coming to this, okay, we measure in this direction. All the distances that are measured from the pole, so pole to focus, it is in the direction of incident rays only. So focal length is what? Then even the radius of curvature from here to here, like this direction. So this is also positive. Only the object distance we measure from here to here. We measure in this direction. So like this we are measuring. So that is also taken as only this is taken as negative minus sign. So and the image distance will be taken as positive because any time for the convex mirror the image is found behind the mirror only. Always it is behind the mirror. So I hope you understood all this. And then what do we have here is whatever it is convex mirror. And then okay, the ray diagrams are almost when the object is placed at the behind the what is this one beyond this center of curvature or of course infinity. Infinity means we get a point size image. We get a point size image for the concave mirror. So then little bit. So behind or beyond the center of curvature but not infinity, the image will be here between F and C. Then if you place it at C, the image also will come at C only, same size, but inverted. Same size but inverted. And then again, if it is on the focal length, the object is exactly at the focal length, you will get the image at infinity. The image will be at infinity, then we can't describe it. Okay, description is not done. Then if you keep it between the pole and focus, then you get a inverted, you get a image which is virtual image. It's the only case. And also it is erect. So the remaining all cases are inverted only. And this is the only case where you get a erect image for the concave mirror. Okay. The only position where we get the erect image for the concave mirror is when the object is placed between pole and focus. Listen once again. The only case when we get a erect image. The only case when we get a erect image for the concave mirror is when the object is placed between pole and focus. Okay, between pole and focus. So this is basic concept regarding your this one sign conventions for okay. Coming to this convex mirror, always the mirror image is diminished and always the image is erect only. Image is erect and image is diminished. Understood? Okay, students. So you just go through this if you want. Okay, all right, students. So I hope you have understood the topic up to now. So thank you for listening. We will continue the remaining. A few problems are there. So that problems we will discuss in the next class. Then we will proceed to the next topic, that is chapter, that is gravitation. Okay. So for all the Muslim students and others also, even so all of you have a happy Maghrib tomorrow. Okay. Right. Thank you. Have a good day.